Determine the equation of the line formed by joining the points a cosine alpha, comma a sine alpha, and a cosine beta, comma a sine beta. Fine. So let us begin. So here, in order to solve this problem, we will be using the point slope form of a line. In order to solve this problem, we will be using the 2-point form of a line. So let's quickly recap what's the 2-point form of a line is all about. So if a line passes through 2 points with coordinates x1, y1 and x2, y2, then the equation of the line is given by this particular expression. So let us begin. So since we have the 2 points, so let's say the first point a cosine alpha, comma a sine alpha, let this be equivalent to the point x1, y1. Such that this is going to give us the value of x1. So x1 will correspond to a cosine alpha and y1 will correspond to a sine alpha. Then we are going to consider the other point, which is a cosine beta, comma a sine beta. So let's say this particular point is equivalent to x2, y2, which implies that x2 is going to be equals to a cosine beta and y2 will be equals to a sine beta. So what we'll do, we'll use the value x1, y1, x2, y2, substitute into this particular 2-point form of a line to get the equation of the line. Now, before beginning, let's do one thing. Let's compute the value of y2 minus y1 divided by x2 minus x1, which is also the slope of the line formed by joining the 2 points. So in place of y2, so here we have a sine beta minus y1 will be a sine alpha, whole divided by, we have a cosine beta minus a cosine alpha. Fine. So further simplification is going to now give us, we are going to get a times sine beta minus sine alpha, whole divided by a times cosine beta minus cosine alpha. Fine. So we can factor out a from both sides, and if we multiply both numerator and the denominator with -1, so we're going to get sine alpha minus sine beta divided by cosine alpha minus cosine beta. Now we have difference of two sine function in the numerator and difference of two cosine function in the denominator. So there's a standard identity. So sine alpha minus sine beta, that's given by 2 times cosine of the angle alpha plus beta over 2 multiplied to sine of alpha minus beta over 2, whole divided by cosine alpha minus cosine beta. So the difference of the cosine function will become 2 times sine of angle alpha plus beta over 2, and then we have sine of alpha minus beta over 2, with an exception that there will be a negative sign. Fine. So here what we can do, we can now factor out 2 from the numerator and the denominator, and we can factor out sine alpha minus beta over 2 from the numerator as well as the denominator. That leaves us with the ratio. We have the negative sign, cosine over sine. The cosine over sine is nothing but the cotangent function. So we have cotangent of alpha plus beta over 2. So this is the value of y2 minus y1 divided by x2 minus x1. Okay, now let's go to the 2-point form. So the 2-point form, which is given by, we have y minus y1 equals to y2 minus y1 divided by x2 minus x1. This is going to be multiplied to x minus x1. So we have y minus y1. So here y1 is going to be a sine alpha and x1 will be a cosine alpha. So let's substitute it here. So we have a sine alpha, this will be equals to this y2 minus y1 of x2 minus x1. This will be simply negative of cotangent of alpha plus beta over 2 multiplied to x minus x1. So x1 will be a cosine alpha. Fine. So we get y minus a sine alpha equals to, so let's multiply to get negative x times cotangent of alpha plus beta over 2, and we have positive a times cotangent of alpha plus beta over 2 times cosine alpha. Now what we'll do, we'll transpose these two terms to the left hand side, and this is going to give us x times cotangent of alpha plus beta over 2 plus y, and then we have negative a whole multiplied to sine alpha plus cotangent of alpha plus beta over 2 times cosine alpha equals to 0. So this is going to be the required equation of the line, which is formed by joining the 2 points. We have a cosine alpha comma a sine alpha and a cosine beta comma a sine beta. However, if we want, we can go a few steps further and further reduce this by using some laws of trigonometry. So let's do one thing. So here we can rewrite the cotangent function as the ratio of cosine of alpha plus beta over 2 divided by sine of alpha plus beta over 2 plus y minus a times sine alpha plus cosine alpha times, so we have the cotangent function which can be expressed as the ratio cosine over sine. So we have cosine of alpha plus beta over 2 divided by sine of alpha plus beta over 2. So this will be equals to 0. Now what we do, we are going to multiply throughout the equation with sine alpha plus beta over 2. So that's going to give us x y times cosine of the angle alpha plus beta over 2 plus y times sine of the angle alpha plus beta over 2 minus a multiplied to sine alpha times sine of alpha plus beta over 2 plus cosine of angle alpha times cosine of angle alpha plus beta over 2 equals to 0. Now furthermore, this can be reduced. So this is nothing but cosine of angle. So this is the expansion of cosine of alpha minus alpha plus beta over 2, which means this will be simply cosine of the angle alpha minus beta over 2. So that means this is equals to 0, this is equals to 0, and the first two terms remains the same. So let's write it down, and we have the term a multiplied to cosine of alpha minus beta over 2. So this is also the correct form of the equation of the line. So you could have either stopped here, or you can use some algebra to obtain the simpler form of the equation of the line.